Hello students, myself Anna Sahib Gorane from RBNB College Srirampur. Now we study chapter from 11th Science, that is optics. In previous lectures we have studied about optics, laws of reflection, laws of refraction, refraction at a single spherical surface, and lens maker's equation. Now today we study about prism formula. Prism formula. The question on this article is like this: for a prism, questions are like this: for a prism, prove I plus E equal to A plus delta, or A plus delta is equal to I plus E. Or another question is like this: derive the prism formula. Prism formula, it gives the refractive index of the medium or prism. So firstly, what is the prism? Prism is a transparent material made up of glass. This is a prism having three rectangular planes, 1, 2 and this three rectangular plane, and two triangular planes, this one and this one. These two are the refracting surfaces of the prism. The line joining the refracting surfaces is the refracting edge of the prism, and the angle between these two refracting surfaces is the refracting angle of the prism. Section of prism perpendicular to this refracting edge, that is this section, perpendicular section, is a principal section of prism. The principal section is triangular in shape, and face of the prism opposite to refracting edge is its base of the prism. So this is the prism having the three rectangular faces and two triangular faces or planes, and we see the prism formula. Now see the diagram. Now in this diagram, this ABC is a principal section of prism. This A is a refracting angle of prism, and BC is a base of the prism. BC is the base of the prism. We draw normals M and M dash on the faces AB and AC. Monochromatic light, that is the light having the single wavelength or single color, is incident. This is the incident ray PQ. It incident at angle of incidence I. At point Q, the ray is refracted through the prism. It changes its direction and it moves along QR. At point R, again the ray is refracted and it moves along RS. This PQ is incident ray, QR is refracted ray, and RS is the emergent ray. Angle made by this incident ray with the normal, we denote it by I, and it is the angle of incidence. Angle made by the emergent ray with the normal is angle of emergence, and angle made by this refracted ray at the two normals, that is at this normal the angle is R1, at this normal the angle is R2. These R1 and R2 are the angles of refraction. If prism is not there, this incident ray will travel like this along this straight line. So this is the direction of incident light. It means this incident light or ray is deviated through some angle. If we produce this emergent ray, then this direction of incident ray and the direction of this emergent ray, suppose they meet each other at point X, and the angle here is delta. This delta is angle of deviation. That is the angle through which this incident ray is deviated. Angle through which the incident ray is deviated. Now see here in the figure, as this is the angle of incidence, this is angle of refraction R1, R2. By the geometry, by the theorem of opposite angles, as this is I, this total angle must be I. But this is R1. We consider this much angle as X. So X plus R1 must be equal to I. Suppose this angle is X. This is R1. Addition of these two angles is equal to I. X plus R1 is equal to I. Hence, this X is I minus R1. Hence, this angle is I minus R1. Similarly, this E must be equal to this total angle. Suppose this much part is Y. So, this Y plus R2 is equal to E. Y plus R2 is equal to E. And therefore, this Y is E minus R2. Hence, this angle is E minus R2 by the geometry. That angle is E minus R2. Now, in the figure, this angle PQM is angle of incidence. Angle M dash RS is angle of emergence. This angle is delta. And this angle A is the refracting angle of the prism. Now, from figure, angle AQN, is equal to angle ARN, and that is equal to 90 degree. Angle AQN is equal to angle ARN, and that angle is 90 degree because these are the angles made by the normal. Hence, these angles are 90 degree. Now, from quadrilateral AQNR, from quadrilateral AQNR, sum of its all angles is 360, but these angles 90, this is 90. Hence, sum of these two angles, that is this A angle and angle QNR, must be 180. Sum of these two is 180 because AQN and ARN, these are equal to 90. 90 plus 90, this is 180. So, from the quadrilateral, sum of all angles is 360. Hence, this angle A plus angle QNR, this must be 180 degree. Very simple part. Angle A plus angle QNR is 180 degree. Now, from triangle QNR, in triangle QNR, we know sum of all angles of the triangle is 180 degree. So, in this triangle QNR, R1 plus R2 plus this QNR This is 180 degree by the geometry. Very simple part. If we compare these two equations, this is QNR here 180, 180. It means from this 1 and 2, we write this A must be equal to R1 plus R2. So from equation 1 and 2, we write very simple equation, that is A is equal to R1 plus R2. Suppose equation number 3. Now see here, this delta is, that is the angle of deviation, is the exterior angle of the triangle XQR. Delta is exterior angle of triangle XQR. And by the theorem of exterior angle, this delta is addition of these two angles. Hence this, we write this delta as angle XQR plus angle XRQ by the theorem of exterior angle. Very simple part. But this XQR is I minus R1, hence we write this delta as I minus R1 plus XRQ is E minus R2. E minus R2. Delta is equal to I minus R1 plus E minus R2. We write next step like this. Delta is equal to I plus E. This I plus E. Now minus R1 minus R2, take minus as common, inside the bracket R1 plus R2. Inside the bracket R1 plus R2. But see from equation 3, R1 plus R2 is A. Hence we write this delta as I plus E minus that R1 plus R2 is A, that is the refracting angle. If we take this minus here, that will be delta plus A, or we write this also as A plus delta is equal to I plus E. This is our one important equation. A plus delta is equal to I plus E. A is the refracting angle of prism. Delta is the angle of deviation. I is angle of incidence, and that E is angle of emergence. Now we see the deviation curve. Deviation curve, that is the variation of angle of deviation with angle of incidence. We plot a graph, and that graph is a deviation curve. We draw the deviation curve. If we plot a graph of delta, that is the angle of deviation versus angle of incidence, along this axis I, that is angle of incidence, and delta, that is angle of deviation. This is the origin. If we plot the graph, the nature of the graph is like this. This is the nature of the graph. These are the different values. Of I and delta. This is the graph. Now what is the nature of this graph? See here. This is the deviation curve for the prism. We plot the angle of incidence and angle of deviation graph. From this graph, it is clear that if angle of incidence is increased from small value, see here for this point, angle of incidence is this much, this is the angle of deviation. Angle of incidence, angle of deviation, angle of incidence is small, angle of deviation is large. If we increase the angle of incidence, angle of deviation goes on decreasing. If angle of incidence is increased, angle of deviation initially goes on decreasing. It reaches a minimum value here. Angle of incidence is increased from small value. Angle of deviation initially decreases. It reaches a minimum value, and then as I increases, delta also decreases. And this minimum value of angle of deviation is called as, or is denoted by delta m. That is the angle of minimum deviation, and at this value, this I is equal to E. At the minimum value of angle of deviation, this angle of incidence and angle of emergence are equal, except at delta is equal to delta m, at the minimum deviation I is equal to E, except at delta is equal to delta m. For any other delta, suppose this value, this is the delta, there are two values of angle of incidence. One is I and other is E, or vice versa, except for minimum deviation, because a principle of reversibility is applicable here. If this is I, the ray travels along this direction, this will be the emergence. If direction of ray of light is reversed, the ray travels along the reverse direction, then this will be I, this will be E. If ray travels like this is I and this is E. If the direction is reversed, this will be I and this will be E. Hence, except at delta is equal to delta m, there are two values of I for any delta. One is I and other is E, or vice versa. It means I or E, or this may be E, this may be I. These are reversible. I or E or I, and this minimum value is delta m, and at this value I is equal to E. At delta is equal to delta m, angle of incidence is equal to angle of emergence. Thus, at delta is equal to delta m, I is equal to E. These two angles are equal. This refracted ray is parallel here, and at this situation, the R1 angle of refraction, these are equal, and suppose they are R. At the minimum deviation, delta is delta m, I is equal to E, and this angle of refractions R1 and R2 are also equal. So R1 is equal to R2 is equal to R. Hence our equation A is equal to R1 plus R2, that earlier equation, becomes A is equal to R plus R. And hence we get A is equal to 2R. And therefore we write this R as A upon 2. Angle of refraction as A upon 2. Now as we know, A plus delta is equal to I plus E. We already derived this part. A plus delta is equal to I plus E. And at minimum deviation, that is delta is equal to delta m. At delta is equal to delta m, we know I is equal to E. Angle of incidence is equal to angle of emergence. Substitute simply these values in above equation. Instead of delta, write delta m, and instead of E, write I. So this equation becomes A plus delta m, that is equal to I plus I. A plus delta m, that is equal to 2I, or this I is A plus delta m upon 2. That is the angle of incidence. Now here we get the angle of incidence, that is I, angle of refraction, that is R. Then by Snell's law of refraction, by Snell's law of refraction, refractive index of the material or that prism, denoted by N, it is sin I upon sin R. Sin I upon sin R. Simply substitute values of I and R in this equation. We write sin I is A plus delta m upon 2 divided by sin R, but R is A by 2, sin A upon 2. And we get this important formula, and this formula is called as prism formula. From this equation we find the refractive index of material of prism if refracting angle A and angle of minimum deviation delta m is known. If question is like this, for the prism prove the relation A plus delta is equal to I plus E, right up to that step only. If question is like this, derive the prism formula or obtain the expression for refractive index of material of prism, then write that further part also. This all deviation curve and this much part. And lastly obtain the prism formula, that is N is equal to sin A plus delta m upon 2 divided by sin A upon 2. Or sometimes this ray diagram may be asked for 2 marks. Draw the ray diagram and for 1 mark and give labeling to it. Draw these arrows. Arrows indicates the direction of light. Okay. Today we stop here. Thank you.